Imagine being stranded on a shipwreck, an island, a dark forest, or in the middle of the desert, and you want to be able to send an emergency message to anyone that might be able to detect it. Our prototype is perfect for you. Firstly, as you can see, there are wires pretty much everywhere. We try to make it as neat as possible, but sorry for the inconvenience. On a more serious note, we have the key component of our project, the printed circuit. It makes the connection between every single element of our prototype. Above it, we have the breadboard in white that simply helps us manage our connections better. On this breadboard, the photoresistor detects whether it's day or night. To create the signal, you have different options. You can either use the keypad that will allow you to send predefined messages by simply pressing on a number. Button switches can also be used to either send dashes, dots, or custom signals, depending on which button is pressed. And finally, the fourth button allows you to switch between the two servos that are controlled by the blue potentiometer when they are in the manual mode. We also have a UART cable connected to our computer that will be very useful to send custom messages directly in text. Then, as you can see on the right-hand side, these white earphones will allow us to hear the Morse signals we are sending. For the signal to also be seen from far away, even during daytime, we will use two servo motors that will display semaphore code, which usually will be done with huge colorful flags. There is also an LCD screen that simply displays the send message. Finally, to be able to see the signal during the night, we will also be using LEDs that will simply blink short or long to create words or sentences. Let's get to the serious stuff and start with the demo. We can start with the buttons. First, the custom length, the dot, and then the dash. As you can see, the LED lights up and we can hear this pretty annoying sound, but that is audible from far away. Then let's emulate the sun shining on our prototype. For this one, we'll have to suppose we aren't in Belgium. Now, the light signals are useless, therefore we will use the servo motors to signal a message. We use the potentiometer to rotate the servo, and then the button to switch the controlled servo. The buttons still function for the sound, but the LEDs are disabled. Then let's see how the keypad works. We have defined button 1 to send the hello message in semaphore, audio, and LED. The 11 other buttons could be used for specific messages such as SOS or anything useful. It is really easily configurable. Next, we'll see how the UART is used. We have coded a website from scratch that allows you to send custom text messages and it be directly translated to Morse and semaphore. There is also a login system which can limit the users or prototype. We will test this with the message OK, for example. As we can see, everything works as planned. Then let's switch to the message SAZ. It probably means something in an unknown language. Again, everything works just fine. There is also a history system to see what messages were sent and exactly when they were sent. For the coding part, we tried to make it as neat as possible. To achieve this, we started by splitting our code into different files, one for each function, to avoid having two long codes at a time. We also avoided using side delays, the classic wait function that freezes the code during a certain time. Instead, we used timers that basically count how many times the internal clock has ticked, and deduces how much time has elapsed between two moments. Once the desired time has elapsed, it creates an interruption that will notify our code. For the audio, we used an 8-bit digital to analog DAC converter to generate sounds with various amplitudes, frequencies, and durations. We also used the opposite of a DAC, an ADC, which stands for Digital to Analog Converter, for the light level detection and the potentiometer position. We also had to use pulse width modulators, PWMs, to generate some modified square signals with duty cycles different than 0.5, for example for the servo motors. All these components can be found in the top design file of our project. We hope that this convinced you to invest in our project to commercialize it and sell it all over the world.